Hello, my name is Jonathan Varner, and I'm a product manager with AutoForm. I'm here today visiting one of our customers, Piper Aircraft, or more specifically, PIMCO, a subsidy of Piper Aircraft. With me today are two of our customers, Jonathan Hilton and Kevin Chisholm. I'd like you guys to both introduce yourselves.
Okay, I'll start first. My name is Kevin Chisholm. I'm the new business development manager here at PIMCO. And I've been with the company for roughly 16 years now.
And I'm Jonathan Hilton, and I'm the project engineer for the day-to-day operations and customer management roles.
Okay, well, showing around today and see some of the parts that you're used to dealing with. I'm from an automotive background, so it's a little bit different. The production styles are obviously different. Everything is still fundamentally, though, a forming operation.
Correct.
And if we go back in time, I think some of the story that you're going to tell, the history of things, what you used to do versus what you do now, I think is what is really interesting to see how things have progressed.
Okay.
And to start off, let's hear a little bit about 2 or 3 years ago. How did you do things? What was your key point when you received a part? You have to create a process for it. You maybe do feasibility for it. You're going to build the tools. What steps did you take, and what kind of key things did you evaluate during that process?
Sure. Yeah, so my previous role before I was new business development manager, I was the manager of the tooling team. And part of that responsibility was designing and building form blocks. We would get a model from our engineering group, and they would take the model and design basically a form block, a male form block typically. And they would have springback calculations. But that was more of an educated guess. So a lot of the times that we would build this tool, there would be many revs that we would have to do to get the tool tiled in.
Yeah. So in that time, the toolbox that you had was CAD. It was wood patterns. What kind of carbon fiber patterns? What kind of patterns and materials? It was all more manual work, right?
Much more manual work, yes. So
trial and error.
we would do, we would make a manual flat pattern, and then we would have to actually trim that into what we think would work, right? Which would often take several tries to get it close.
It's a lot like when you are doing a home improvement project and you're cutting a 2x4. If you're supposed to cut it 60 inches, you measure twice, and you cut once, right? And it comes out 1 inch short every single time.
Right.
So we try to avoid that process. So we would always try to work towards the final product. So we'd always be iterating and moving up and trimming more and massaging the tool into place till we get a final product. One of the advantages with AutoForm today, though, is we can pretty much jump right to the end. So we have tooling in place and simulation in place that can show us what we can expect on the shop floor, which then eliminates iterations that go downstream.
So when you're developing this now, if we switch from that history of doing things manually, it was experience-based, it was trial and error, it was a lot of extra on-the-floor work.
Correct.
You've tried to move that into a virtual space now.
Right. So again, in the past, your craftsmen that you had to have do these tools, the skill level was much higher than what's required today. Again, you'd have a guy on a manual mill cutting out the shape of the die, if you will. And if you go back further than 5 years, they would cut them out with a bandsaw. They had this machine that had a rotary file on it. It was literally just a continual bandsaw, if you will, of files, and we would work in the springback angles into our blocks. It was very labor intensive. It was rudimentary at best, right? It was a very not scientific skill, if you will.
Yeah.
But today, with AutoForm, again, we have CNC mills that we use, and with AutoForm, we develop flat pattern. We develop tool design, and our tool design methodology has changed as well. Instead of using primarily male dies, we use a lot of draw dams or
Cavity tools.
Cavity tools, yes. Sorry. And so it's changed our methodology and how we form. And with the draw type tool, we get a much more consistent part because you can control how the material flows onto the die.
Right. And you say, I think you said before, you kind of discovered this through playing around using AutoForm or simulation to kind of say, if I flip this over, what's going to change for me? How does the blank look initially? And that's kind of where you gravitated towards that style.
Of course. Working with AutoForm, their team's been fantastic. Honestly, they've helped us guide a lot of our tool designs and our thought process on how metal forms. And, they looked at the way we did things in the past. And then they gave us ideas of, hey, this is how you should look at it in the future. So it really did change how we thought about tool design in general. So with the guidance of AutoForm and the experience of our tool makers and tool designers, it's really formed into this tool making that is really, it's almost one shot at this point. We design a tool, build a tool with confidence today.
Okay, and that's a key point I'd like to come back to right now, just to make sure everyone understands what your full role is. You start with part, you develop the process, you design the tooling, and then you produce the tooling, you follow it all the way through. So that's kind of we'll say a special niche. There's a lot of times people are looking at feasibility only, or they look at only die design, or they look at I'm the try guy.
Right.
So how would you describe that as your strength or your weakness?
Yeah, so at Piper, PIMCO, we have a very unique capacity here, capability, in the fact that we do full tool design, tool manufacturing, and we run the parts as well. So it's full gamut. So you can bring us a part, and we can, again, design a tool, build a tool, run the part, and fully inspect that part. So when you come to us, we can do a turnaround in as little as a week if it's necessary, which I would argue that there's not very many companies in the entire country that can do that.
Okay.
I also just want to say that the vertical integration that the facility has here really tends itself to that aerostructures concept that we work with them. So raw material runs through one door, and then airplanes or aerostructures or whatever the final product is can roll out the other side of the facility. Very interesting just from a concept-wise, just because the vertical integration just isn't around as much anymore.
Right. Yeah, and that's what a lot of customers say. When they come on site and they actually see our capabilities, they're just absolutely amazed with the fact that really from cradle to grave, you can have a part under the same roof, which is very, very rare today.
Yeah. So that's what you would consider one of your key kind of value propositions to not just Piper, but the companies that you might be doing contract work for, right?
100%, and that's the uniqueness of PIMCO. We're now offering all the capabilities that Piper has to other companies or customers to PIMCO. So,
okay. And I think a key point there is going back to like some similarities between, let's say, philosophies or methodologies, is that idea that you simulate what you know you're going to build, you build what you simulate. That's not a direct connection for some people. That's, commonly we see this, but for you, you're doing it all, so therefore it's automatically part of your process.
Correct.
And that's a key.
And it's a unique perspective for me because this is what I'm used to. This is what I know. And it's crazy that the opposite for most companies. Like they have to go a la carte to every single different vendor that they have to go to get a specific tool made. That's new to me. But that is our 100% strength.
Yeah. So that all of that then, that's a lot of virtualization. You kind of touched on the physical world, but when that switches over to a tryout, I think you said it once before, but when you hit the tryout, what do you expect to happen the first time you go into the press or the first time you're dealing with that part?
Today with AutoForm, we expect it to form with
and
a very high degree of confidence.
If it doesn't, what is your first step after that?
We'll go and look at the processes, right? Because when you're forming metal, it could be you have a heat treat process, you have you might hit it with no heat treat at all, or grain direction. All kinds of things matter. With our equipment, we use Quintus flex forming equipment, and obviously we can hit at low pressures or very high pressures. There's any number of sequences that we can do to make a part successful. So, but knowing that the tool through simulation, it should get us there. We know the first step is not to look at the tool now. Now it's to look at the actual process. Yes.
Very good. Well, I think for today, for right now, you guys are very exciting kind of guys. I can tell you're very interested in the industry in general, and we're all forming guys. So it's nice to see kind of a different perspective of some of the parts that you make are something I wouldn't want to touch because I'm stuck in the mentality of, you know, a million parts a year, but it's very exciting, and we appreciate your time for today.
Yeah, thank you.
And we thank everybody for watching.
Yeah, thank you.
Thank you.